to show you where you're going tomorrow night for your exam. So this class is all going to Follinger, F1, A through E in the balcony, and F through Z on the floor, Follinger floor. I'll send you an email too, but it's posted here. If you happen to be in the 2 p.m. class, just sitting in here right now, there's your assignment. If you happen to be in the conflict, everybody in 314 Alt Guild, except if you're at the end of the alphabet, M through Z. In R1, you're going to 100 Greg. Any questions? Okay, so now, what we're going to do is just go over that practice exam in your notes, just a show of hands. How many people have already done it? All right. Maybe of those people who've already done it, how many people have particular questions? Raise your hand. Okay. Now, before we begin, are people still mystified about the Monty Hall problem? Do you want me to go over that? Raise your hand if you do, or raise your hand if you do. Okay, we can try to go over that quickly. It's kind of a fun problem. I won't spend very long on it. Okay, let's check it out. So this is a very classic, famous problem, a counterintuitive problem. So the idea, as you all know, is you get to pick one of 3 boxes here and just shout out a box. Okay, now, if the car is in here, what's the chance the car's in here? 1/3. What's the chance that Monty Hall, I'm going to be Monty Hall, a game show host, what's the chance I have the car? 2 out of 3. Okay. Now, I'm going to peek inside the cars. I'm going to cheat, and you're going to see it from my point of view. I'm going to peek inside here. It's in 1. See? It's in 1. See, 2/3 of the time it's going to be in here, right? So now which box am I going to open? Am I ever going to open 1? If I know it's in 1, do you think I'm going to open that box and show you the car? No. I'm always going to open the empty box. Do I always have at least 1 empty box? Yeah. I either have 1 empty box, like in this case, this is the empty one, or if you had the car, I'd have 2. So when I open this box, does that change the chance up here that 1 out of 3 times you have it? No, because all I'm going to do, watch, all I'm going to do is show you an empty box. Does that change that 1 out of 3 times it's going to be up here? Does it? No. 2 out of 3 times it's going to be down here, and I'm always going to have an empty box. I'll either have 1 empty box, or I'll have 2 of them. So it didn't change the chances I had it. It just shows you now that 2/3 of the time I have it, and now 2/3 of the time it's going to be in that closed box. So 2/3 of the time you should trade. Yahoo, you won. Let's try again. Now let's just pick another box. Now, when I open this, does it change the chance that you know this is 1 out of 3 times you're going to have it. 2 out of 3 times I'll have it. Let's open the box. Oh, I didn't want to open the box. Well, now we don't know. I wanted to peek inside. But don't you know that 2 out of 3 times I'm going to have it? So 2 out of 3 times, now I've shown you 2 out of 3 times it's going to be in that box. And 1 out of 3 times you'll still have it. Let's cheat. It's in 3. Okay, trade. Win or lose, we won. All right, let's do another one. Now, do you understand that what I'm essentially doing is this. What if I asked you, we don't know which box it's in, 1 out of 3 times it's here, and 2 out of 3 times it's here. What if I asked you at this point, do you want to trade your one box for my 2? Would you go with that deal? For sure you would. It's really the same deal. It's really the same deal. Because when I open up one, I'm not gonna, you know I have an empty one. Don't you know? Can I have 2 cars? Are there 2 cars? So isn't one of these gonna be empty? So when I show you an empty box, I'm not telling you anything new about your chances. Your chances are still 1/3. My chances are still 2/3 down here. When I show you an empty box, all I'm doing is saying that 2/3 chance that I have is now all inside of the, is like when I open one of them, that 2/3 chance is all in here now. That's all I'm doing. So it's like, it's as if I'm giving you 2 boxes. I'm giving you an empty one plus the other one. 2/3 of the time, the car is going to be there. Does that help? Does that help explain it? Raise your hand if it does. I'm curious. Anybody else want to have a better way of explaining it? Go ahead.
If you use 10 boxes instead of 2 or instead of 3, it's a lot easier to like.
Are you the one who wrote that on the thing?
Yeah, that's me.
Did you see my response?
I did.
You said, okay, he says if you use 10 boxes, it's easier to see. Imagine you have 10 boxes. 10 boxes. So we can just go over here, and that was a very good, it was a really nice thing that you wrote, but I just want to show you something. Okay, so he said, oh no, did I not bring, all right. Always need paper here. All right, 10 boxes. And this doesn't even look good here, does it? Let's zoom in and make it pretty. All right, so now there's 10 boxes, and you pick 1 box. You pick 1 box, and how many do I have left? 9. 1, blah, 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 is the first one. The second one, all the way through to 9 boxes. All right, and here's your box, and they're all closed. What's the chance that you have the car? Out of the 10 boxes, what's the chance you have the car? 1 out of 10. What's the chance that Monty Hall has the car? 9 out of 10. Now, Monty Hall opens up all his boxes except for 1. He opens them all up, and they're all 8. He opens all 8 boxes that he has. He opens them all up. So let's say he opens up all these, they're all open, and this is the only closed box. That's the only one. Does it tell you anything about this? Does your chance change here? Did he tell you anything? You know he has 8 empty boxes. There's only 1 car. So you know he has 8 or 9 empty boxes, okay? So does it change anything about this? This is the same. Does it change anything about 9/10 of the time? 9/10 of the time he has what? A car. All he does when he opens all his boxes is he told us that 9/10 of the time the box is going to be right there. He just showed you which box it's in. That's all he did. You don't know which of the 9 boxes it's in. You know he has 8 empty boxes. He might have 9 empty boxes. 1/10 of the time it's going to be there, and that one's going to be empty too. So when you switch now, you have a 9/10 chance. Does that help you see it? Is that how you thought of it? Does that help you see it? No? You wrote 1/10. You wrote 1/2.
It wouldn't let me change it.
Oh yeah, don't worry. A question. Online Kappa. Are you able to delete your answers? Can't you just delete your I'm not online Kappa, on the discussion board. I see all these people, saying things, and then they say, never mind. Why don't you just erase your original comment? It won't let you? Oh, that's terrible. I'm going to have to talk to the creator of that. That's awful. See, I can erase my comments. You can't? Awful. All right, now it's time for, don't worry, I'm not going to ask anything that difficult on the exam. All right, should we start at the beginning? Or do you want to start front? Vote. Front to back or back to front? I can't hear. Front to back, raise your hand. Front to back. Oh, okay, it's obvious. That's what you want to do. Okay, so let's look here. Now, you're going to have something very similar to this. What I would do first is look at the positive ones. This one's positive, and which one's positive? This one. Can you see that? These two are negative. All right. Now, so look at these positive correlations. Now, which one hugs a line more? This one. So it's going to be closer to 1. Closer to 1. So don't you see it would be that? Any questions on that? So we've got that one out of the way. Now let's look at the next positive one. Well, there's only one other positive one, so that has to be C. All right, now we've eliminated those two. Now let's look at these. Which one hugs a line more? It's going to have a stronger correlation. This one. So it will be closer to -1. Okay, closer to -1. And you see how -0.90, -0.9 is closer to, has a stronger correlation. So B goes there, and that's weaker. And so that's your answers. Does everybody see that? Okay, make sure you know how to do those. Next one. It's never appropriate to use R if you have a curve. So this is going to be no, you can't use R when you have a curve. And not when you have two separate sets of data, because R would make it look like it was a positive correlation when you two separate, so that's no too. All the rest are okay, even if it's all, this will correctly give you 0. So all the rest are yeses. Any questions on that? Okay, now let's look at this next one. This is kind of people had trouble with this one. People had trouble with this one. I remember this. Okay, X and Y are two sets of numbers with the same average and the same standard deviation. Do you know anything about how they're paired up? Do you know anything about how they're paired up? No, you don't know anything. All you know is the box they're in. That tells you the standard deviation and the center. So they could look like this. That has about the same standard deviation spread in the X, Y, and X. Or they could look like that. They have the same center and the same spread. No, it doesn't tell you anything about it. This is not enough information. Okay? Questions on that? That's how we started off when we first started talking about correlation. If you recall, that's one of the first things we did. We said the statistics of the scatter plot. All eight plots have the same averages and standard deviations. The only, but you don't know how they're matched up until you know R. All right, let's look at another question. The slope of the regression line is 0. If the slope of the regression line is 0, that means that whatever slope of the regression line is 0, y equals 0 x plus something. I don't know, whatever. Let's say plus 3. That means whatever x you put in there, there's your scatter plot. It's just the average of the y's. You'd always predict the average of the y. It tells you nothing. No matter what you know about x, does that tell you anything about y? You're going to be multiplying by 0. That tells you that R is 0. So what's that? Oh, R is 0. That's what you're supposed to learn. Oh yeah, R is 0. If the slope is 0, then R is 0. Questions? All right, what's the next one? The regression line has a negative slope. And what does this even mean? That's the root mean square error. Do you remember what that is? The square root of 1 minus r squared times the standard deviation of y. That's 0. That's equal to 0, and then there's a negative slope. All right. Well, if that's equal to 0, it means all your errors are 0. All the errors have to be the same, and since some are positive and some are negative, they all have to be 0. So what is that? That says the typical distance. This is the same as the standard deviation of the errors. Look. So that says r is 1. R is 1 or negative 1. The only time that's going to be 0 is when you plug in r1 or negative 1. And it's negative 1 because it slants down. Does everybody see that? Questions? Is that hard? It's just the language. Okay, so what are we going to do with that one? That one is what? Exactly negative 1. All right, whenever you say y is exactly 0.5 times x. So this is just saying what? Y equals 0.5x. That's an equation for a line. The slope is positive. As x goes up, y goes up. As x increases, doesn't y increase? The bigger x gets, the bigger y gets. Isn't that true? So what should I do for this one? And it's an exact. It's an equation of a line. Y equals a half of x. Oh, why am I having so much difficulty? It's too early in the morning. For me. Y equals 0.5x. So what should I say? Positive 1, exactly. Years of education, oh, come on, you know that's not going to be an exact relation, but you know the more education you have, the more income, so that's going to be what? Somewhere positive. And the weight of a car and how many miles it gets per gallon, that's going to be somewhat negative. So does everybody see that? I gave you a hint, too. I said that you have to check each box exactly once. Each column has to have a check in it. Yeah. All right, any questions on that? All right. Please tell me if I'm going too slow or too fast. Slow? Too slow. Raise your hand. Too fast. Raise your hand. Just right. Raise your hand. All right. Okay. If x and y are two sets of numbers, correlation equal to 0.6. Correlation equal to 0.6. Okay, what happens? This is about what happens to the correlation coefficient when you make change all the x's or all the y's by either adding something to all of them or multiplying them all by something. Let's look. If one is subtracted, is that going, do you know the rule? Adding or multiplying, it's like what you just have to review is it's chapter 7 and it's right at or chapter 6 maybe. Yeah, chapter 6, just the summary. So let me look. Yeah, right here. I'll just review it for you. Adding, this is all you need to know for these. Adding the same number is not going to change R. I'm on page 89. Multiplying all the values is not going to change them. Changing units. If you measure something in centimeters instead of inches, is that really going to change the relationship between, the linear relationship between height and weight if you change your units? We went through this, but basically the z-scores will always stay the same. No matter, if you just make a linear transformation, like adding all the same, you're just shifting the graph over if you add the same number to all the x's. Same number to all, if you subtract, you're not changing the relationship. And if you multiply all the x's by something, yeah, you're changing the spread, but then you're dividing, to get a z-score, you're dividing by that same change, so the z-scores wouldn't change. So you don't, the only way that you're going to change something through a linear transformation like that is what? If you, what about if I multiply by a negative r? If I not by a negative r, but when I multiply by a negative number, then the sign of r would switch. Okay, that's the only thing. Any questions on that? I don't want to go on too longer about this because we've done it so many times. Questions? So for example, if I multiplied by -2, let's say the correlation was 0.5, r is equal to 0.5, and I multiply all x's by -2. Then the correlation between x and y, you have two sets of x and y's and it's r is equal to 0.5. Okay, you have a whole bunch of x's, a whole bunch of y's. You know, that's it. You know, points. Multiply all the x's by -2, the correlate r was going to be what? Not 0.5, but what? -0.5. That's all you have to remember. Okay. And switching all the x and y's doesn't change. The correlation between x, y, and yx is the same. But if you just switch, if you just do something to one particular x or one particular y, yeah, it does change the correlation. All right, let's go back. I don't want to waste too much time on that. So I think now, do you really want me to do these? I don't think so. Don't you think you can get these on your own? The last one. If all the original x and y's are converted to z-scores, think about it, would the correlation coefficient change? No, it would still be 0.6. That's how you compute the correlation coefficient. You change them to z-scores. That's what you do on the way. Would the correlation coefficient change at all? The slope of the line would change, possibly. The slope of the, not the correlation coefficient. That's how you get the correlation coefficient, right? By changing to z-scores? Okay, do you want me to do any of the others? Do you really want me to do them? Do any of them change? Look, okay, if one is subtracted, no, it's not going to change. You get 0.6. If you multiply by a -0.5, yes, that will change. We'll change the sign. But nothing else will here. Does that make sense? Does that make sense? All right, let's go to the next one. All right, takes a while. Do people really want me to do this one? Because it takes a while. How many people want me to do this? How many people don't want me to do it? The majority don't want me to do it. You know what I'm going to do is I'm going to get through all the ones that are a little bit more difficult to do, and then I'm going to let people leave, and those who want to stay can. How's that sound?
Sounds good.
Okay. So this will be one we'll skip for now. Now, after being given a dose of a certain drug, the average pulse and blood pressure for a group, 5 groups of 20 were recorded. Okay, the correlation between pulse and blood pressure for the 5 pairs of averages was 0.91. Can you conclude that the correlation between the 100 subjects is also 0.91? You know, this is an example of ecological correlations. And the answer is no. When you add, within each group, there's going to, when you change it to 100 points, within each group, you're going to add a lot more scatter. And generally speaking, you're going to, tends to, when you add more points, when you add all the within group scatter, it will increase the scatter, which will lower the correlation. Example of that, we did, and just the picture, to keep the picture in mind will be so much easier than any words. Here's the picture I showed you. Imagine that all 4 guys from state A, 1, 2, 3, 4, 5, 6 guys from state B, and the rest are from state C. these correlations based on averages, called ecological correlations, that's what we're doing here, called ecological correlations, they eliminate all the within these state scatter, within group scatter, and what's left, do you see how these points hug a line more than these? So ecological correlations tend to inflate R. This is going to weaken the correlation, not always, but usually. Do you see? Read this over. And any questions on that? Any questions? So when you add, right here you're just looking at the between group scatter, and you've eliminated all the within the group scatter. All the individuals inside group state B, and all, same with this. So it tends to make it more scattered, and so ecological, your draft lottery example is another example of that. That when you condensed all 365 days into 12 points, it had a much stronger correlation between when you were born and what your number was. Okay, so what's the answer to this? Where were we? The answer is, can you conclude that the correlation is the same? No, you definitely can't conclude that. So that one's out. Now, more points are probably going to give you more scatter, not always. So more points will give you more scatter, which will lower the strength of your, weaken your correlation. Yeah, this one. Okay, any questions on that? It would weaken the strength of your correlation. All right, studied, do you want me to do, let's see, this one. What's this one about? Negative correlation between the attractiveness of a defendant and the fine they received for a misdemeanor. That's the true data here, isn't that sad? That even the cops or even the law is judging a book by their cover, a person by how they look. The scatter plot below shows the attractiveness rating made by police officers, 0 to 10, and the fine they received. Now, what's it ask? The average attractiveness. This is where the point of averages is. So if you're talking about attractiveness, go down here, and it looks like it was what? 6. How about for fine received? That's on the X, and it looks like it's about what? Sometimes, you know, it's hard to see. What I would do is just take a piece of paper and just try to go straight across. And I'd say it looks like what? 100, and there's 100, 110. Right? Okay. Okay. The regression, the SD line is always steepest. It's always steepest, and the regression is always flattest. So which is the steepest line? That's really steep. So that's the SD. Yeah, imagine skiing down that one. And this is the regression. It's always flatter. This one's always steeper. SD is steeper. Regression is flatter. All right, so which one did they ask for, by the way? 'Cause sometimes I'll ask for one and sometimes I'll ask for the other. This is the regression, so it's the solid line. Questions on that? Does everybody know that? All right, now how do you know the correlation? You have to compare those two lines. And I guess the best way to compare them, remember we always said, is to just draw a straight line right through point of averages, draw that triangle there. And then, well, here we have a line right here. Draw any triangle. It's very convenient here, though. And if you consider this 0, and this, what's this? Let's say 1 or 100. Where does it intersect that line? Like if this regression line had a 0 correlation, it would be right there. Be right there. If it had 0.1, it would keep getting steeper and steeper until if it was a correlation of 1, it would be all the way up here. So, Just mark it off. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Well, I didn't do it very well, but what are my choices? It's negative, isn't it? It's negative. I could have drawn the line this way. Maybe that would have helped you. It's negative. How far down do I go? 1, 2, 3, 4, 5, 6, 7. Oh, it's a hard one to see. I'd see it's negative point. That's not a choice. Oh, yeah, it is. Negative 0.5 is right there. That's what we thought it was. Good. It's negative. Great. Questions on that? All right, next one. Which of the label points has a residual close to 0? Well, it has to be on the regression line to have a residual close to 0, so it has to be this one. So that has to be observation 4. Has to be on the regression line to have it, because the regression line makes a perfect prediction. Next one, looking at the scatter plot, about what find does the regression equation predict for someone who's only 3? Ah, they're going to get a high find just because they didn't think they were that attractive. Awful. It's way up here. What is it? Look over, I'd say it's about close to 200. Did I what?
You answered E.
Oh yeah, I'll go back to it. 3, what was it? It's not all the way up to 200. Looks about 150. No, it doesn't look 150. Attractiveness rating of, what did I do wrong? What did I do wrong? It's the mistake you're going to make on your exam. I'm looking at the wrong line. What line should I be looking at? The regression line. I'm looking at the wrong line. That's so good. They're not going to get that high a fine. So I want to look right here. And that is about 150. See? And then I skipped one. Which of the label points has the residual closest to 0?
We did that when you answered it for F.
No, yeah. My eyes are terrible. I just realize this point is almost impossible for me to see and see you out there at the same time. Which of the label points has the largest possible residual? Which one does? Which one's furthest? I would say it's that one, wouldn't you? Furthest off the regression line. I'd say it's observation 2. What would you say? Does that make sense? Okay. The average of the residual is always 0 because the positives and negatives cancel out. And what if this observation 5 was deleted? Where is observation 5? It's way off the line. So I would say it strengthened things. It has a pretty big residual. So I said it would strengthen it, make it closer to -1. It would make it stronger. If it's way off the line, it's going to, if you remove it, it will strengthen it. Any questions on that? All right, let's move on. Now, the scatter plot below shows the GPA. You can tell, you can do this, A, right? The ones above the line did better than predicted, and the ones below the line did worse, right? They're just asking you. Look, we have one, look, did he do better than predicted? 1 and 3? And this one, who did better than predicted? 1 and 3. Who did worse than predicted? 2. Did anybody do the same? No. If they did the same, they'd be right on the line. Any questions on that? Questions on that? But this one did almost the same. This one did almost the same, almost the same. All right, now let's look. Now here, you have to know how to do these regression predictions by changing to a z-score. So what do we want to do? What do you have to do? First of all, you have to pay attention up there. And so 16 hours, what do? You say minus the average. And what's the average for GPA? 10. divided by the standard deviation for GPA, which is 4. And so what do we get? 16 minus 10 is 6 over 4. So that is equal to 1 point what? 5. Then you multiply that by 0.8 and you get what? 1.2. Always closer to 0. 1.2. Now what do you want to do with that 1.2? That's not 1.2. What is that? 1.2 what? If you want to, you can start at the average for GPA. What's the average? 3. This tells you you're going to be above average. Above average by 1.2. Does that mean the person is going to get a 4.2? Can you even have a 4.2? I think it only goes up to 4, right? It's 1.2 what? What are these things? Standard deviations. So you put in the standard deviation here, and what's that? 0.5. Is that correct? And so then you get 3.6. All right, now what about 8 hours? So you say 8 minus 10 over 4. And what's that? It's negative 0.5, right? Isn't it? And then you multiply by 0.8 and you get negative 0.4. And you do the same thing, but this time you're going to say plus negative 0.4 times 0.5. So now you're going to be below average. That's what this tells you. Below average by what? Below average by 3 plus negative 0.2. So you'll get a 2.8 there. Any questions on that? Those you should do pretty easily. Oh, this is a good one. I'm going to do one just like this. I haven't finished writing the exam. Very good, because now you get a way to check your work. I like this. I have to finish writing the exam. Oh, I really like this. Watch. Now you can check your careless mistakes. You're going to do the regression equation another way. You're going to predict GPA, that's what we're doing, from study hours. But now here's your other method. I want to make sure your answers check out. So let's get this equation. So I say first get the slope. So how do you get the slope? You say the slope is equal to what? R times the ratio of two SDs. Now is it y over x or x over y? What do you think? Y over x. So you have 0.8. Now, which is y and which is x? Predicting GPA. So GPA is y. Whatever you're predicting is y. Do you got that? Whatever you're predicting is y. You know, it's on the y. So now, which one was GPA? So now we have, so it must be 0.5 over 4. Correct? Does everybody see that? 0.5 over 4, which is equal to what? 0.1. So that's what you put in here. Any questions on that? That's why I said it's 0.1 is look what I got. I got 0.4 over 4. 0.4 over 4. All right, so I stick that in here. Now you want to know this. So far I have this equation. And what can I do? I can write it here. GPA equals 0.1 times your study hours times the study hours plus something. So I'm going to stick in any point on the line. So why don't I stick in, the only point I know is the point of averages. So I'll put a 3 in here times 0.1 times 10 plus b. And I'll solve for b. So b right here is equal to 3 minus 0.1. So it must be what? 3 minus 1, excuse me. 3 minus 1, so it must be 2. That must be my answer. Right? This is 1 plus 2 equals 3. You subtract that from both sides, so you'll get b equals 3 minus 0.1 times 10, which is 3 minus 1, which is 2. There's your equation. Now, check your arithmetic by using this to make sure it agrees. What do I mean by that? Check it out. Put in 16 and see if you get 3.6, do we? Put 16 in here. If we do, we'd say 0.1 times, we'd get 1.6 plus 2 is 3.6. It checks out. So you can check your own work, so I'm not going to give you much partial credit. You can go back and check your own work. All right, let's go on. In most scatter plots, what percent of the points are within like 1 standard deviation of the regression line? And what percent are within 2? You know what this is? This is asking you for this, basically that standard deviation rule of thumb that's applying to regression lines. And let me just show you where that came in. I think it was in chapter 8, which was one of your least favorite chapters, if I recall. So I think it's this, right here on page 100. Remember I'd said about 68, let's change this to 68% are within 1 standard deviation and about 95% are within 2 standard deviation of the errors? That's where that comes from, so yeah. So we'll just say about 68 and 95. All right, now next question. What are we doing here? If you regress y on x, and is the regression of y on x the same as the regression of x on y? No. Everything changes. Remember, mothers whose sons are, mothers who are 5'9" have sons who are 6 feet, but sons who are 6 feet don't necessarily have mothers who are 5'9". Remember, that changes. You get a different equation. So everything would change. The r stays the same, but these two change. All right. Unless there's a perfect correlation, they would change. All right, let's move on. Now, okay. Here I gave you the regression equation. It says that the number you drink is 1 times the party hours plus 0.3. What's the best interpretation of the slope? Well, the slope says what? The slope is drinks per party hour. For each extra hour of partying, every single girl, oh, this is for girls, every single girl in our class consumes exactly 1 more drink. That would be true if there was a perfect correlation. We can't say that about every single girl. There's scatter, so obviously that's wrong. For each extra hour of partying, girls in our class consume about 1 more drink on the average. That sounds right. It's not possible to interpret the slope since some girls in the class don't drink while others may. Yeah? We're not saying it's exact. We're saying it's a regression equation. It takes into consideration. It's not going to apply for every person. Okay. Now, what's the best interpretation of the y-intercept? Well, in general, the y-intercept is always what y is when x is 0. So when party hours are 0, what's y? It's about the average number of party hours per week for girls who have 0 drinks per week. That looks good. No, it doesn't. It's when party hours are 0. It's about the average number of drinks per week for girls when they have party hours 0. Whoa, you have to read it carefully. It's not possible to interpret the y, because it's outside the range of the data. You can't party negative hours. I'm not saying to party negative hours. I'm saying you can party 0 hours. I'm proof of it. And that's what the y-intercept is. Okay. Any questions on that? Now, standard deviation of the prediction errors. This is one of those ones you're just going to have to know the formula, but look at the form that I gave you. So it's pretty easy. Standard deviation of the errors. It's the same as the root mean square of the errors. Standard deviation of the prediction errors. This is one of the ones you're going to have to remember, but it's not very hard because look at the form I'm giving it to you in. It's the square root of, and I'll do the same on the exam, 1 minus r squared times the standard deviation of y. So it's one of these two. Now, which one is it? Which one is it?
With the 9.
Which one's Y? Predicting drinks. So you just have to say Y. Standard deviation of predicting drinks, so it has to have the 9 there. So it's going to be this one. Okay, any questions on that? All right, I tell you, it's not about memorizing formulas. The one you should know though, is the slope. I mean, this one you should know, but it's not that hard if I give it to you in that form. But the slope is what? R times the standard deviation of Y over the standard deviation of X. Is that hard to remember? Not really, I hope. Okay, now we're on probability, and these, okay, this is about these diagnostic tests. And follow the directions carefully because it makes it easier for you here. Before we do this, why don't we do one on percentiles? Those are kind of hard. And you're definitely going to see one. And let's just keep to regression and then I'll go back to that one. Is that okay? All right. Okay. If X and Y follow the normal curve but have different correlations among different populations, imagine a population where there's a perfect correlation. All right. If there's a perfect correlation, and here's test X, and you're trying to predict test Y, and R equals 1, then wherever you are, here it's the 8th percentile, it will always match up with the 8th percentile. You don't need averages, standard deviations, anything. They're going to have the same z-score. This is basically already in z-scores. So the 8th percentile is going to match up with the 8th percentile if R was 1. Does everybody see that? What if you had the 30th percentile? That would match up with the 30th. That's what R equals 1 means. You'd have exactly the same place on the two curves. What if R was equal to -1? R is equal to -1. Then what would you have? Then you would have the 8th percentile Now we're -1. Think about it. This is the 8th percentile. When you have -1, you're going to get an opposite z-score. So it's just going to be the opposite. This is a negative z-score multiplied by -1. You're going to get a positive z-score, but the same number. The same number. Here you're going to get the same z. Whatever this z is, you're going to multiply it by 1 and you'll get the same z. So your z's are going to be the same. Here, whatever your z is, in this case it's going to be a negative z, you'll multiply it by -1 and you're going to get the positive z. So this is the negative z, you'll get the positive z. So it won't be the 8th percentile. What will it be? Can you figure that out? What'd you say? Yeah, instead of being 8 from the bottom, you'll be 8 from the top. Here you're 8 from the bottom, you'll be the 92nd. They'll have to add to 100. Another way to look at it is, this is the 50th. This is the 50th. This is 42nd down. You're 42 below. Here you're 42 above. You're just exactly the same, only the same z-score, only the opposite. Does that make sense to people? Check that they add to 100. All right, now, what if R is equal to 0? That means you know nothing. So let's just take that same 8th percentile, you know nothing about test Y. It has nothing to do with it. Now, where are most people? Are you going to, look, it's highest here. So guess the 50th. And whatever z-score you got here, you would multiply it by 0. That's what you do. and you'd get z equals 0, which is right there. All right? Does that make sense to people? Yeah? Now, what about in between those things? The in between ones are hard, but you know, for example, if it was in between, is that all that I asked here? But what if it was 0.5? R equals 0.5. I just want to show you that where would it have to be? R equals 0 is the 50th. R equals 1 is the 8th. So 0.5 is between 0 and 1. It would still be, look, let's just do it. Okay. I just want to give you an intuitive idea. If you actually had to come up with an exact answer, all right, so you still have the 8th, which means that is 8%. You get some negative z here, negative z. We don't know what it is. Now, you get that negative z, you multiply it by 0.5, and you're going to get only half the z, negative 0.5 z. So it's going to get closer somewhere. It'll be between the 50th and the 8th. It's going to get closer to 0. That's z equals 0. How would we do it, though? Let's do this one. Because unless I told you, gave you a multiple choice, and the only answer was between 8th and 50th, you could just circle it. But what if I asked you to actually calculate it? How would you do it? So you'd say 8 here. You have to get that z. What is that z? You have to get a middle area. So you make 8 here, and that leaves what? 16, 84 in the middle. 84 in the middle. So you'd look up 84. You'd look up 84. And what would it be? I don't know what 84 is. 84 in the middle would be 1.84 in the middle? 1.4, is that right? Is that right? So what does that tell me? 84 in the middle. Do you see why I get 84 in the middle? It has to 84 plus 16 is 100. All right, so now I know my z must be what? Negative 1.4. And this is positive 1.4. So I take my negative 1.4 and I multiply it by 0.5. And what do I get? Negative 0.7, closer to the average. So I'll mark negative 0.7. I don't know. You're going to have it marked off. So here's like, anyway, pretend that's negative 0.7. So I say, okay, it's going to be a bigger percentile. But how do I find out what it is? I don't know what that is. So I look at my chart, negative 0.7. And I look at my chart and I say, negative 0.7. I'm going to round that to 52. But what does it mean? It means 52 between negative 0.7 and positive 0.7. That's what that means. So now I go back and I say, okay, I'll write down 52 right away before I forget it. But it means between, it's the middle area. And I want all that, it's gonna, so what is that percentile really? I know it's gonna be between 8 and 50th, but now I know exactly where it is between 8 and 50th. What is it? It's between 8 and 50th, but what is it? Well, you have to think what? 48 for the two of them. 48 for the two of them. So what's each one of them gonna be? 48. 24 and 24. So that's my percentile, the 24th. And sure enough, it is between the 8th and the 50th. Does that help? Do you get it? Let's see what the problem is. It's probably, did I do exactly what's in here? Oh, I did exactly what's in here. All right, let's do it. I did it exactly what's in here. All right, so let's just fill it in. I can't believe I did exactly what's in here. Okay, so Imagine a population where there's a perfect correlation. Well, then the eighth is going to be with the eighth, the same. Negative correlation. Then this is 8 from the bottom, so now you want 100 minus 8, which is 92, 8 from the top. Now, imagine a population where there is a 0 correlation. That will always be the 50th, z equals 0. Now, what do we want to do? Imagine a population where it's 0.5. That's just exactly what we did. Sorry, guys, I didn't even read it. Okay, 0.5. Well, now you can do it. Mark the 8th percentile. 8th percentile means 8% lower. 8% there, that means we can't really mark it until we get the z-score. 8% there, that leaves what in the middle? What? 84 in the middle. Then we look up 84, and what did we get? When we did it, we looked it up and we got between 1.4 and negative 1.4. So there we have negative 1.4 multiplied by 5 and we get negative 0.7. And now, did I ask you to shade anything? Shade. Why did I'm just shade 8, it's low. If I asked you for the 90, anything above 50, you'd have to shade the middle area too. It's everything below. 8th percentile is not good. I hope you don't score 8th percentile on our exam. Okay, now, to get this percentile, now we know we've moved closer to the average. That's regression towards the mean. And now we look up between negative 7 and positive 7, and we said we got 52, which left 24 here. And now that is your new percentile. You see, you went from the 8th percentile, if you're at the bottom, you regress towards the mean to the 24th. All right, that's it. What's the next one ask? What if you were at the 92nd percentile? Well, the 92nd lines up completely, but pretend we started from the beginning and didn't see this. All right? Once you have this, it's very easy, but what if I started with the 92nd? Well, then I would say 8% on top. Why? Because 92nd means 92nd below. 92% are below. So then I'd have 8 here, and again, 84% in the middle. I'd look it up, and it would be 1.4. It's exactly the same thing. The only difference is I'd shade all this. And then it's a positive 1.4, and that's the negative. Because it's above average, so you'd have positive 1.4, positive 0.7, and then between 0.7 and negative 0.7, negative 0.7 and 0.7 is 52 plus 24. It would be all that, which is 76. All right, now we can go back to that other one. Sorry I spent so much time on this. Now we can go back to that other one, the diagnostic test. And what can we do for this one? All right, so it's important I gave you a big hint here of where to start. And what did I say? Fill in the blank first using this information. Okay, out of the 500 people, only 8% really have hep C. So we take 8%, 0.08 of 500, and that is 40. So now we know 500 minus 40 don't have hepatitis C. Now we read our next piece of information. 95% of those who have will test positive. 95% of these people, 0.95 of the 40 will test positive. So that's equal to 38. That means 2 test negative. But then we have to use this. 5% of the ones who don't have it are going to get false positives. So 0.05 of the 10% is 46. 5% would be 23. 0.05 of the 460, which is 23. So we subtract 23 from there, and we get 437. We add them all up, and we get 439. And here we get 61. All right. Now, person tests positive. Where do you look? They test positive, a total positive 61. How many of those really have hepatitis C? 38. All right. Person tests negative. Where are they? 439. How many of those really have it? That's only 2. Okay? Any questions on that? Now let's do the last page. Did anybody have trouble reading this? Do you want me to go over this or not? Why don't we do this one first? This is reading a chart, pretty much. Okay, now this one. Suppose a machine contains 10 fair dice. The machine shakes up the dice and then randomly spits them out without replacement. And okay, what's the chance the machine first rolls out a red? Well, how many red are there? 5. So what are out of the 10? So what's the chance? 5 out of 10. What's the chance it first rolls out a 5 and? So 5 out of 10 and is times it lands a 5. How many times is it going to land a 5? 1 out of 6. So what's that? 5 out of 60? Do I have one of those? Oh, I actually didn't write it out. Okay. What's the chance, sometimes I will say 5 out of 60. What's the chance that the machine rolls out either a 5 or a red? Well, a 5 is either a red. 5 out of 10 plus, what's a 5? 1 out of 6. Now, can it do both? Yes, you just figured out both. So it has to be minus that. Is that one of the answers, or do I have to? Oh, it is one of the answers. Okay. Sometimes I'm going to actually, because I don't have enough space, I'm going to condense it. So make it smaller. What's the probability that first is a blue and the second is a blue? First is a blue. How many blues are there? Out of 10. And the second is a blue. We multiply. And the second is a blue without replacement. Whoa. So there's only 9 left. How many blues are left? 2. Is that one of the answers? Okay. What's the probability that none of the first rolls are 5? Whoa, none of the first rolls are 5. We have to take it one by one. What's the chance the first one isn't a 5? How many possibilities are there? 6. Right? Because there's 6 different things, the first one. What's the chance? 5 out of 6. How about the second one? Is it with? Yeah, but is it with without replacement? Oh, but it's the same thing. It doesn't matter. We're not replacing that one. The next die comes, and shouldn't it be 5, 6 to the third? That is confusing, though. Did you get confused by this? Okay. What's the probability that at least one of the first rolls is a 5? That would be 1 minus that. What's the probability that the first 2 rolls sum to 3? How many ways? There's 36 possible ways they can sum. And you have to think of sum to 3. You can get a 1 out of 2, 2 out of 1. Is there any others? 2 and a 1? Is there any others? So that's your answer. Those are kind of tricky, didn't you think? That's probably the first three, at least one. Which one was this one? Okay. All right. And what's the probability that none of them are? Did I circle anything here? I did it, but I didn't circle. Which one was it? It's this one. So sorry. Whoa. Huh. Okay. How many people could do those probability ones? Raise your hand. Great. That's terrific. Okay. Now, anybody had a particular question on their own? Why don't you just come down and everybody else can leave?